In this presentation, we're going to look at an algorithm, and an algorithm is just a logical series of steps to solve some type of problem. The problem that we're going to look at today is, given a random list or array of values, how can we find the two largest values in the list? So a very common problem is to find the largest thing or the smallest thing. That's either the minimum or the maximum value in a list. In this case, we want to find the second largest value in the list, or the top two largest values in the list. So how might we do that? To start off with, we might start with the maximum. How would you find the largest thing in the list? And the idea is that you store a variable. You have a variable that's going to store the largest thing, and you initialize it to something really small. And you go through every item in the list and you ask, is this item larger than the current largest thing? And if it is, you replace it. If it's not, you move on to the next value. When you've gone through the entire list, the thing in your maximum value will be the largest thing in the list. So let's start with that algorithm and then see how we might modify it to find the second largest thing. So I've got a project already created. I'm just going to add a new source file, maybe call it largest CPP. And the first thing we'll do is create a list of random values and print it out. So I will need a couple of includes. Main function, and we'll create a vector of, and it doesn't really matter what data type. In this case we'll use integer, and that will be our list. And we will create a loop that fills the list with 5 or so numbers. Random numbers between 0 and 25, say. We can create a function to print the list. And for efficiency, we might want to pass this list in as a constant reference, so we don't make a copy of it every time we print it. So we'll print them out one line at a time, or print them out all on one line. And we only have 5 things in the list, so it should fit fairly well. And then after we've created the list in main, we can call our print list function and pass in the list. And pretty straightforward program here. We get a list of random values. One thing to notice is that each time we run this program, we'll notice we'll get the same set of random values, and the reason for that is that the random number generator is based on a seed, and if you don't specify a different seed, you'll get the same series of random values if you don't specify a different seed. And one way to seed the random number generator is with a time based on the system clock, with a time value. And you can look up how to do that. The function to do it is called srand, and you can just put some value in there, and then you'll get a different set of random numbers, but it'll be the same set every time you run it because we're using the same seed here. If you want to get a different seed every time, you've got to put in a call to the system time. Sometimes when you simulate or test things, it's useful to actually have the same series of random numbers so the same events can occur, so you can duplicate them and see what's going on in a program, in a test, or in a simulation. Alright, so now let's write a function that will find the maximum. And again, we'll pass in our vector and we're going to loop through the list, and for every value in the list, instead of printing it, we're going to compare it. If the value in the list is greater than the current largest, then we're going to set the largest equal to the value that we found that's larger. So for every item in the list, if it's greater than the largest, we will set the value in the variable largest. Now, before we start the loop, we have to declare it and initialize it. And what should we initialize it to? Since we the value that you initialize it to depends on your data set. Since we know that the values in the list are all going to be in the range of 0 to 25, then it might make sense to initialize it to -1 or something really small like 0, -1 or 0. In general, if you don't know what the values in the list, you should use the minimum value for that data type. And C++ has constants defined for minimum and maximum values for each data type. So I think there's a value called int min, and it's defined as the smallest value of an integer. And there's a float min and max and a double min and max and so on. So when we're done with this loop, the variable largest will have been replaced with the largest value in the list. So we can return it like that. And then we can print out call our find max function and passed in the list. So if we run that, let's see if it works. You can see that we're getting the largest value of 19. And let's step through this in the debugger so that we can understand how it works. And this is another really useful use of the debugger I encourage you to try. If you're not sure how a piece of code works, or if it's working properly, step through it line by line in the debugger and watch what happens. So in this case, I'm going to put a breakpoint on the for loop, and I'll run the program with debugging, and largest is set to something really small, and I is going to start out at 0, and list sub I, or list sub 0, is 16, and that should be greater than the largest, so that should replace largest. So that ends up true, and now largest is replaced with the 16. The next time through the loop, list sub I is 1, So list sub 1 is 17. That's greater than largest, which is 16, so largest should get replaced again. And you can see that that happened. The next time through the loop, list sub I, which I is 2, is 9, and 9 is not greater than the current largest, so we should skip over that if test, and we do. So in this case, we're stepping through the code, verifying that it's doing what we think it should do, and that's a good way to learn how algorithms work and to test or verify that your code's doing what you think it should do or what you want it to do. So I'll stop debugging. And now we want to look at, we found the largest, how could we find the second largest? How would you modify that? Well, one algorithm, and there's different ways of doing it. One possibility is there are well-known sorting algorithms, so you could sort the list in either ascending or descending order. And that would be relatively easy to do. And then the largest one would be, in the case of ascending, in the case of descending order, I guess, the largest one would be the second item in the list at index 1. The problem with using that technique, though, is that it potentially does a lot of unnecessary work. So if you have a list of 1,000 things, you're sorting 1,000 items, putting them in order, and all you really care about is the second largest. So it's doing extra work. So another possible algorithm here might look like this. We go through each item in the list, and if the item is greater than the largest thing in the list, we are going to replace the largest. But also, we're going to keep track of the second largest thing. And if an item is greater than the largest thing, we're going to, before we replace the largest thing, we're going to put that largest thing in the second largest variable and then replace the largest. Else, if the item is not greater than the largest, we check to see if it's greater than the second largest thing, and if so, we replace the second largest variable. And notice the order of these if statements. This is important. We have to ask whether the item is greater than the largest thing first. It's important that we ask that the item is greater than the largest thing first, because if the item is greater than the largest, and we were to ask if the item was greater than the second largest first, that would also be true, because the second largest is always going to be smaller than the largest. So the order of these tests is important. So let's see if we can write that function to find the second largest. And it's going to look similar to this. And we call it find second max. And we're going to have a largest and a largest 2. And another thing to point out is that using the variable name max might be a problem, because I think max is a function in the standard namespace depending on what header files you include. So max and min are standard functions. So we've got these two, and this part is good, except we need to modify it to support this algorithm. And before we replace the largest, we want to put what's currently in largest in the second largest. So we're going to say largest 2 equals largest. So if we found something bigger than the largest thing, something bigger than the max, we want to move the current max into the second max, or largest into largest 2, before we replace largest. And then the other part of this then is to just check to see in the else, if it's not greater than largest, it might be greater than largest 2, and in that case we just want to update what largest 2 is and return the second largest. print out the second largest in the list is find the second max. And if we run this, we get that the max is 19 and the second largest value in the list is 17, and that looks to be correct. And we could try it with a larger data set. And we got a max of 24 and a second max of 20, and as we scan through the list, it looks like 24 is the largest and 20 is the second largest, so it seems to be working. So this is a little tutorial on how to develop algorithms, and it's similar to one of the problems that you'll be working on. And please let me know if you have any questions.